All right, this last video is just analyzing the graphs of what a log function looks like. And so it's going to have the same rules as the exponential functions before. So if you see a format like this, where you have a number out front, that's the same as your initial value for an exponential. And that's going to flip it over the x-axis if it's negative. It's going to stretch it vertically if it's greater than 1 or less than -1. And it's going to compress it vertically if that number is between -1 and 1. So if it's like -0.5 or +1/3 or something like that. Don't include 0 because that'll make it all 0. It will go left or right if you add or subtract a number in the log from the x. And it's always going to be the opposite of what the axis will tell you. So if it's minus, it's going right, plus is going left. And if you're going to add or subtract a number at the end, it'll shift it up or down, as you would expect. Let's take a look at the graph of just a general log function before we get into analyzing these. So remember, 2 to the x power, if I do y equals 2 to the x power, that's an exponential growth function. And what a log function looks like is if I want to use that same base, I'll do y equals log, type in log, and you can do shift minus again to put that subscript. And there's a base of 2. And then right arrow, and you can put x in the parentheses. That is the inverse function. So the reason they're inverse functions is because if you were to switch x and y and solve for y, it's gonna give you this, and we'll get into that in another time. But notice that these two functions are going to be reflections over the line y equals x. So that's going to split those two graphs in half. So the inverse of 3 to the x power would be log base 3 of x. You see that? And the same thing for 10 to the x power would be log base 10 of x. And remember that if it's log base 10, it's the common log, so you wouldn't need that 10 in there. But the idea is that these functions are going to pretty much act similarly. The only difference is how they open up. So exponential function opens up real quickly as x goes to the right if it's a growth function. With logs, they open up slowly. Okay, the further x goes, the more and more it's going to keep rising, but it's going to get slower and slower growing as it goes to the right. It doesn't flatline there, but it'll never cross over the y-axis. And that's because you cannot put a negative, if I do log base 2, and I try to put 0 in there for that matter, it's going to say undefined. That's because you cannot raise 2 to a power and get 0. And similarly, I can't put a negative number in there, so it's undefined. So this graph will never cross over the y-axis. So it actually has, instead of a horizontal asymptote, it has a vertical asymptote of x equals 0. Excuse me. Let me hide those two for a minute. So this graph will never cross over x equals 0. And if I move the graph, let's say to the right, I could do -4. Well, that would shift that vertical asymptote to x equals 4. So it's never going to cross over 4 in this case. It'll still open up quickly. So let's go back to 2 to the x power. And I'll get rid of this for now. If I want to shift that, if I want this to cross over the x-axis, I'm still going to put a negative out front. Okay, so that's going to flip it over the x-axis. If I want to stretch it, I'm going to put a number bigger than 1. So maybe I'll put 6. And that'll make that graph stretched out here, basically taller. If I want to compress it, I'm going to make that number be between 0 and 1. So maybe 1/3. And that kind of flattened the graph and made it shorter. Okay, it's still going to cross here, but it's increasing at a much slower rate because of that 1/3. The negative wouldn't change the fact that it's still compressed. It just means that it's going to be flipped over the x-axis. All right, how do I shift this to the right? Well, I can do in the parentheses -3, and that would go 3 to the right. If I wanted to go left, I could do +4, and that would shift it 4 to the left. See, that's opens up at 1 here, and -3, that's 4 units to the left. Let's say I want it to go up or down. That's going to affect the end. So if I want it to go up, I would say +2. We'll go make it go 2 up. And notice it's crossing differently now. So here at 1, it's at 2 instead of 1, 0. It's crossing the x-axis here at actually 0.25. If I want it to go down, maybe I want it to go down 6. I just do -6. So that's the idea behind these. Let's see if we can identify, for example, 5, the movements. We'll do that one together, and I'll have you try this one on your own. So -5 times log base 4 of x minus 3 plus 4. It is always implied that the number in the base would be what would the parent function be. So it's coming from log base 4 of x. That would be the parent function. And we want to know, how does it move from log base 4 of x to give you -5 times log base 4 parentheses x minus 3 plus 4. So I always start with if it's got a negative, treat that number first. That negative is going to make sure it reflects over the x-axis. So if it does not have a negative, it will not reflect. Now let's look at the 5. That 5, whether you interpret it as -5 or +5, it's going to be greater than 1 if you're looking at the 5, or less than -1 if you're looking at the whole number together. It's going to stretch that graph out because it's bigger than 1. So it's going to stretch vertically. There's such a thing as stretching horizontally and vertically, so I'm going to make a point to write the word vertically on here and not just stretch. We don't do anything with the 4 because the parent function would have 4 as the base. So the x minus 3, that's going to take it 3 units right or left, but because it's minus, it's going to think about the opposite. It's going to go right 3 in this case. So it would be translated right 3 units. And the +4 at the end is going to shift that up 4. If it were -4, it'd be down 4. So that's basically it. You just want to identify the types of transformations. Sometimes there's 4 of them, sometimes there's less. Try this one on your own. See if you can do it, and pause the video, and I'll put the answer up. All right, I have my answer written, so if you haven't worked the whole problem out, keep it paused and try it first. This doesn't have as much. This only has 2 things affecting it. It's got a 0.5 at the front and a 5 at the end. So the 0.5, is that going to stretch or compress it? Well, since that is a number less than 1, it's between -1 and 1, that's actually going to compress it. There is nothing in the exponent, or nothing in the parentheses rather, so it's not going to go right or left. The +5 at the end, though, is going to shift it up 5 again. But there's no negative, so it's not reflected. It's not going right or left. So we only have 2 movements, compresses and goes up 5. So that's it. Hopefully that was helpful. You should be able to do all your problems on the assignment. Let me know if you have any questions.